Another patterns question here in 2016. Long question. Now, definitely spend a wee bit of time reading through this for yourself. We'll try and go through it quickly, but it does take a wee bit of foot about and getting used to it. So, in the first bit, they're telling you what's happening here. So, at this point, it's moving across 4, and then it's going up 2, and every time it's going to the left, and it's going half the distance as it went before. Yeah. So it started off, sorry, it's not always going left, but started off, it went 4 units to the right, then it went 2 units up, now it's starting to go left, then it went left 1 unit, and then it went down half a unit. Each time it's half in the amount, and it's going to go a quarter, an eighth. So once we see it's getting halved, each previous term's getting halved, we know it's a geometric sequence. It's got a common ratio. So we're into them formulas there, a common ratio. So look at the diagram in your exam paper and see what you make of it. Now the first bit here, how many stages is the point completed when the total distance, now that word there, total, is key, because once I see it's the total distance and it's a geometric sequence, I know I'm going to be using this formula. Sn is equal to a 1 minus Rn over 1 minus r. Now there's two different ways to do this. You can use a formula, or you can just keep writing out and working out how many terms it's going to be. It won't take you that long. I'll show you using the formula first of all, probably the more difficult way. How many stages is the point completed when the total distance it has travelled along its path is 9.73 blah blah units. So here's my geometric sequence. From that, I can identify the first term is 4, and my common ratio is 2 over 4, which is a half, which applies for T3 over T2 as well, and T4 over T3. You know, always divide by the previous term. So now I'm going to fill these in, and I know my sum total. My sum total there is 7.9375. 7.9375 is equal to A, 4, 1 minus R, which is a half, and that's what you're trying to work out. How many stages? That's what you're trying to figure out over 1 minus a half. Now, once I see this, I'm trying to work out a power. I know I'm probably going to be using logs here. And once I see a half as well, it's probably going to be easier to write it as 0.5. But anyway, we'll start tidying it up. So 7.9375 is equal to 4, 1 minus 0.5 to the power of n. It's only that to the power of n. Over 1 minus a half is 0.5. Now what I'm going to do here is bring up my half. 7.9375. Bring up my half. And I'm going to do 2 stages at 1 here. No, I won't. 4 times 1 minus 0.5 to the power of n. Now you're just trying to get this bit on its own. So we're just trying to tidy it up. Next thing I'll probably get rid of is that 4. So 7.9375 over 0.5 divided by your 4 is equal to 1 minus 0.5n. Now don't be doing anything daft like taking them away. That's all stuck onto the power. So what I'll probably do at this stage is, I don't like the way that's a minus. I'm going to bring that over there. Bring this all over here. Now you could horse that into your calculator, which I probably will do, see what it spits out. So I've left with 0.5 to the power of n is equal to 1 minus that mess there. So 127 over 128. 1 minus that is just going to give me 1 over 128. Yeah. So 0.5n is equal to 1 over 128. That's looking a lot better. Still not hectic looking, but in order to solve that power, I'm going to have to do logs of both sides. And if I go log to the base of the half, think of it, log 5 is 1, log 10 of 1, log a half is 1. So log to the base is 0.5 of 0.5n. And if I do that, I must do it on the other side as well. Log to the base is 0.5. There you go. But the beauty of the logs, I can bring down the power. and then throw that in your calculator. So log to the base 0.5 of 1 over 128.7. I thought this would be a lot shorter. Disaster. Oh, squeeze it over here then. That's it done. It takes 7 stages. Another way, if you were struggling with that, your second way here could have just simply been, I've got 4. Next thing, it's a sum total. I'm going to add on a half. Then I'm going to add on half of that, which is 1. Then I'm going to add on another half. Then I'm going to add on a quarter. Then I'm going to add on an eighth. You know, keep going on till you get your 7.9375. So how many terms do we know it is going to be? We know it's going to be 7. 1, 2, 3, 4, 5, 6. We'll probably have to add on a 16th as well then. So if we did add up all those, 4 plus 2 plus 1, sure we're already on 7. Plus a half, plus a quarter, plus an eighth, plus, sure we'll leave it at an eighth. We're on 7.875, nearly there. Add on a 16th, 7.9375. So you say it takes 7 stages, and that'll get you full marks as well. Part 2 of that, I'll squeeze it in here, so just leave the space up there. So part 2, find the maximum distance the point can move along its path if it continues this pattern indefinitely. Now that word indefinitely or infinitely is crucial, because once I see that, I know I'm using this formula. And the same terms, A is 4, R is a half, or same values in. A is 4, 1 minus a half. So if we keep adding on terms, we're at 7.9375 up here. We're going to get closer and closer to, throw out in your calculator, 8. You know, so not a million miles away. Right, part 3. There. Complete the second row of the table below, showing the changes to the x-coordinate of the first 9 times the point moves to a new position, hence or otherwise find the x-coordinate in the y, blah blah blah. And again, it says actually it continues indefinitely. Definitely or infinitely, I know I'm using this. Now they've already started it off. You can see there it moves x coordinate, it moves 4. Then it had no change in the x coordinate, that's why there's a 0 there. And then it went back along your x coordinate minus 1. Then it's no change in your x coordinate. Again, because it's changing the y. Now I would be thinking about this, I would be doing both of these together. So changes my x coordinate, no change in my y. Next one, change my y coordinate, went up 2. That's the 0.40, now it's the 0.42. Then it went back. So it goes 2 steps forward, positively, 2 steps back, left and left, 2 steps forward, 2 steps back. So it's always going to be alternating plus plus, minus minus, plus plus. And these terms here are always going to be 0. So x, y, x change. So no change in your y. X change. Y change then, going down. And what's that going to go down by? It's going down, and it's going down a half of that. Yeah? So I would just throw in these zeros and just see a wee pattern emerging. Then I'd go 4, half, 1, or 4, 2, 1, half. Next one's going to be a quarter. Half of that's going to be an eighth. Then a 16th. Then a 32. And then 1 over 64. And now look at our signs. Plus, 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 minus, minus, plus, plus. So plus, plus, minus, minus. Goes left or right now. Plus, plus. And it's going to go minus, minus. So plus, plus, minus, minus, plus, plus, minus, minus, plus. Took a wee bit of work at. Now looking at our x coordinate, it says hence or otherwise find the x coordinate and the y coordinate if it continues indefinitely. So you've got to look at these x coordinates. My x coordinate, my first term, that x coordinate is 4. My common ratio is minus 1 over 4. Term 2 over term 1. The term 2 means the second term of your x coordinate. Same here, a quarter over minus 1 is minus a quarter. bung that into that formula. 4 over 1 minus quarter. Throw that in your calculator. (16 over 5) or 3.2. So that's going to be your x coordinate, and for your y coordinate, again, no point taking that as your first term. That's your first term, your y coordinate, where you get your common ratio. But you can't divide by 0. So my first term there is 2. The common ratio is minus a half divided by 2, which again will give me my minus a quarter, and then throw it into that. 1 minus minus a quarter. When you put that in, you get 8 over 5 or 1.6. So therefore, what does it say? Find the position that the point is approaching. So the point, therefore, points are written as x and y. So your point is 3.2 and 1.6. Now, there's another bit to that question. 8b. Better reading at the top, spend your time going through it, but you can nearly guess by the bits they filled in for you. A male only spits out a female. Male only spits out a female, while a female spits out a female and a male. A female spits out a female and a male. So here, and your fifth ancestor, your female is going to spit out your female and your male. The words at the top are very confusing. Your male only spits out a female, and your female spits out, again, a female and a male. So the number of ancestors in part 2, the first bit they ask you to complete it or so. The number of ancestors in each generation can be calculated by the following. And we'll do this rough and ready, but I think you should make sense of it. Where g of 1 is 1, g of 2 is 2. So g of 1 is 1, that means there's one term in it if you like. G of 2 is 1. G of 3 is 2, 1. G of 4 is 1, 2, 3. G of 5 is 1, 2, 3, 4, 5. So what this is saying is, if I take g of 3 here, g of 3 is got by adding the two previous. So if n plus 2 is the term previous to that's n plus 1, and the term previous to that is n. So g of 3 is got by adding up the previous two. So 2 is got by adding 1 and 1. 4 is got by adding up the previous two. So there the 3 is got by adding your 2 and your 1. And g of 5, it's got by adding up the previous two. 2 plus 3 is 5. So use this formula to calculate g of 6. G of 6 is got by adding up the previous two, so g of 5 plus g of 4. So g of 5 is 5. How many terms are in it? Don't complicate it. G of 4 is 3. So g of 6, 5 plus 3 is 8. And then they've asked you for g of 7. So I'm going to add up the previous two terms. Previous two terms we've worked out. G of 6 now is 8 plus 5, which is 13. If you want to check if you're right, wouldn't take you long. Female, male, male always spits out a male, female, male, female, male, male always spits out a male. How many have you got? 1, 2, 3, 4, 5, 6, 7, 8. And you could do it again for your g of 7, you know. And then part 3, the number of ancestors in each generation can be calculated using the following. Use this formula to verify the number of ancestors in g of 3. So sub in your 3 for your n. Your n's been replaced by your 3. Throw it in your calculator if you like. 2 cubed root 5. And I'm just going to say you get g of 3, you're going to get an answer of 2. Try it and see. Right.